Hello. Hi, everyone. Woo. My very first Laracon, so I'm kind of excited. And as Ben warned me, there's just no way to see you guys. The only thing I can see is the many Apple logos glowing in the dark. That's about it. Looks like us folks in the PHP space have a fetish for plush toys. So I'm going to kind of try and match Ben's plush toy, which was kind of big, with some elephants. Yeah, this is one of a kind. Has a nice story behind it. Maybe we'll have some time to tell it later on. These folks here will go to you guys at some point during the presentation. By the way, has anyone here ever been to ZenCon? Yeah, a couple of you. What's that? So if you had been to ZenCon 2015, you would know that I'm a notoriously bad thrower. So if you want to get a chance at winning some of those, or one of those, the folks sitting at the front have much better chances. Anyway, let's get started. Quick introduction about who I am. So I have 3 daughters, which is just absolutely an amazing excuse to do all sorts of things with those plush toys, like this and that. And I can say that I didn't do it for myself, I did it for my daughters. Truth be told, they're also getting into it. This is actually what my oldest daughter did, her own. She did a nice elephant rainbow there. I'm a photography enthusiast. Usually I lug around my DSLR pretty much everywhere, but this time around the DSLR compartment was filled with elephants instead. I'm crazy about spicy food, seriously crazy. I have not yet met people who are so addicted to spicy food as I am, but if you want to try and match me or challenge me, I'm available. I've been programming since the age of 12, beginning with GW Basic. Anyone in the audience ever do that? And then a bit of Pascal, C, C++. I actually have C++ CGIs in my resume, which is, anyone ever do that? Right? I hope not. Ben kind of raised his hand. Not recommended. But it did get me to the right spot, which eventually led to my involvement with PHP. Yeah, already covered that. So I want to begin by actually giving you a quick, sharing a quick version of a story of how I got involved with PHP. Back in 1997, I was studying computer science, and one of the things you have to do as a part of your studies is actually do a few hands-on projects. One of the hands-on projects that was available was creating a shopping cart. Again, a very basic one. Back in 1997, that was considered a pretty complex project, and it had a lot of academic points attached to it. And my friend and colleague back then, Andy Gutmans, we were looking for a project to take together. And I looked at this project, creating a web shopping cart, and I told him, Andy, look, this is really, really easy. I know this language from work. I've never used it, but a colleague of mine from work is using it, and he's saying that he can create web apps with very little effort. We can take this project, do it in a minimal amount of time, and get a lot of academic points. Sounds like a win. He was a bit reluctant in the beginning, but eventually we went for it. And I remember, it was many years ago, almost 20 years ago, I remember pretty vividly that when we came to the instructor, the professor that was leading this project, that was accompanying this project, and we said that we were going to use PHPFI, she was, at first she said, what? Because she's never heard of it. And afterwards she said, why? Because all of the other students were using Perl. Perl back then was the king of the web. Everyone was using Perl. There were like 10 other couples that were doing the projects, and literally each and every one was using Perl, and we came with this thing that she has never heard of called PHP-FI. And eventually, her too reluctantly gave us the green light to go ahead and use PHP-FI. And she had one warning. She said, if you bump into issues, that's your problem. You're going to be gated on that as well. So if you want to go for that, I'm giving you the green light, but take notice that you're taking a risk here. Surely enough, we kind of dismissed her warnings, and we started working on the project, which of course involved no coding. It involved a lot of writing documents and design and all sorts of things like that, what tools we're going to use, defending those decisions, and so on. And then after maybe a month or month and a half, we actually sat down to start coding. And then about 30 to 45 minutes into the implementation, we kind of, to this date, the same development methodology works. You edit a bit of code, you switch to the browser, do a reload, and see what happens. So we do that, we do a reload, and we get a parse error. And we go back to the coding, try to figure out what you were doing wrong. And we're reading it again. There wasn't too much code, only 30 to 45 minutes worth of code. And at some point, after playing with the code a bit, we reached the conclusion that there was actually nothing wrong with the code. The language was not kind of understanding its own syntax, which was the first for us because, coming from, C and C++ and Pascal and even GW basic background, I don't recall I've ever seen a situation where where valid syntax was not understood by the language. So we had the luxury of PHP-FI being open source, so we said, okay, let's take a look. Let's see whether we can fix it. And then we opened the parser file, I think it was, to understand what was going on. And any mechanics in the audience here can tell what's wrong with this car that haven't seen this slide? Okay, so it took me a few years to figure out, kind of to understand and illustrate the way I felt when I actually saw what was under the hood, but basically that's what's wrong with the car. It has a couple of mice rotating the engine. So it was really great. It was a language. It was working pretty well, but under the hood you had mice that were making the engine go. And I remember it was kind of like shock and awe. On one hand, you're shocked that it was written this way. On the other hand, you're awed that it actually worked as well as it did, given how it was written. So then the next step for us was to actually send an email to Rasmus Lerdorf. And I have to admit, almost 20 years later, that it wasn't a very polite email. We're kind of young and dumb. And to paraphrase it, it was more or less like, what the hell were you thinking when you wrote a language this way? And he replied to us much more politely, I have to say, and told us the equivalent of, look guys, works for me. I'm not a computer science major. I wrote it for my own use, and I opened it for other people if they find it useful. So if you find it useful, great. If not, you don't have to use it. Which back then, given our situation, which was on one hand we had this project that we needed to complete, and the instructor told us ahead of time that if we bump into issues, it's our problem, and we'll be gated accordingly. And also we had some other motivating factors like needing to study for all sorts of boring or ridiculously hard courses like numeric analysis and physics that for whatever reason you have to take for computer science when you do this, when you take it in the Technion University. So we decided instead to go and try to re-implement the language, just to kind of see how far we can go. We didn't have any expectations. We just wanted to see if we can do it better. We really felt dangerous because it was literally the previous semester we took compilations techniques, and we felt like we were experts because we took one course in compilation techniques. We were ready to make a revolution in the world. And we got pretty far eventually. We created an implementation of a language which was similar to PHP-FI, but it was kind of more full-fledged. It has many of the traits that you see to this date. Basically, it's statements and expressions-based, which PHP-FI wasn't. The order of evaluation. Basically, it was kind of like PHP-FI, but turned into a really full-fledged language following a similar syntax. And we created this over the course of a few months. We created it side by side with developing the shopping cart application that we still had to hand in. By the way, at some point, I tried to interest the instructor in this mini rewrite of the language, and she said, I don't want to have anything to do with it. Don't talk to me about it. I only care about the shopping cart project, which in retrospect was good. And we had an implementation that was more or less working within a few months. And then to shorten the story, we were pushed by our compilations techniques professor that we got in touch with to circle back with Rasmus and actually try to make this implementation an official successor for PHP-FI. The compilation techniques professor also happened to run the IBM research lab in Israel. He had the very clear view that there were too many development languages, computer languages in the world, and he didn't want to be even indirectly responsible for the creation of another one. So if we managed to convince Rasmus to actually collaborate with us as opposed to create a new language, he would feel a lot better. And somewhat to our surprise, when we sent Rasmus the email, he got back to us again very quickly and said that he was actually hoping that someone would do that. And he agreed to move over to our implementation. And that's more or less how the PHP project as a multi-person project was born after being a one-man project for a few years. So fast forward to year 2000, about 3 years later, that was probably actually not probably, it was definitely the first and last time where it was feasible to get all of the people, or almost all of the people working on the PHP project in one physical location. Today it's just impossible. So you see here a bunch of different people. Some of them you probably know by name, if not by face. So first of all, we have Andy. That's Andy here with his wife. That's Rasmus over here. We have Dave Zmievsky, Frank Kroman, Tis Arnsen, Stig Bakken. This guy tried to become the governor of Nebraska a few years ago, and thankfully failed. He wasn't actually one of the developers of PHP, but he was Andre's boss, and he decided to kind of latch onto him and join the discussions. That's Monty Videnius, who is the author of MySQL. David Axmark also for MySQL, and that's me. That's what I looked like almost 20 years ago. So, by the way, that's the Church of All Nations in Jerusalem. So we managed to actually get most or almost all of the people who were working on PHP back then to one physical location in Tel Aviv and try to kind of plan our hostile takeover of the planet, which was just before PHP 4 came out. And that's that was a major step in PHP's popularity, as we're going to see in a second. So the last element of, oh, I lost, hold on. Yeah, it for whatever reason stopped projecting. Okay, and now it's with the wrong resolution. I should, okay, not doing anything. Try this again. Okay, it's scaled out, it's going to come back. Okay, so last part of the story. I used to try and illustrate, how popular PHP is, and I used to have all sorts of numbers, like the numbers of domains using PHP, websites, books on Amazon, user groups, and so on. For me, the thing that drove the point home in the most powerful way is an experience I had back in 2008. I flew with my wife over to Argentina for our honeymoon. We landed in Buenos Aires. We went to our hotel. I think it's a 2-star hotel, something not very fancy at all. And we check in after a very long flight. And back then, you still had to kind of fill out a form in the beginning with your name and your address and phone number and all that. And I handed it in to the clerk, and he slowly types it into the computer. And then as he types, at some point, he pulls up his face and asks me, Zeev Suraski? It's like, yes. The PHP guy? It's like, wow. Man, if it makes it into hotel clerks in Buenos Aires, that is a good indication that it's really, really popular. So, thank you. So that guy turned out that he was building a social network for San Telmo, the neighbor in Buenos Aires that he lived in, and he was using PHP, and he knew my name, which was really awesome. So yeah, by far the best indication for PHP's popularity. The most scientific one, too. Okay, so next I want to talk to you a bit about the evolution, what led to PHP 7. And I'm going to go over quickly the major versions of PHP, that at least the ones that I've been involved with, starting with 3. So PHP 3, what we started in 97, it was released in mid-98. It was, as I said, a full-fledged language. And perhaps the most important element of it wasn't so much about the syntax or the performance or reliability. Those were important. I think that maybe the most important thing was that it was very easily extensible. You could add extension modules, the ones that you're used to using to this date, very easily and without having to actually change the language call. Back in the PHPFI days, if you wanted to add a new function, you actually had to hack the parser and the scanner, which was just kind of, in terms of barrier to entry, it was needlessly high. So the fact that we made it easily extensible created a boom in the number of extensions, and PHP started really supporting all of the different databases, all of the different protocols very quickly, and it was really a force multiplier, because unlike before, where practically it was Rasmus that had to implement almost all of the different functions, now people could easily write their own functions and add them and contribute them. PHP 4, that's kind of the version where we realized that instead of turning this car from using mice into using like a V8 engine, what we did is actually maybe turn it from mice into rats. And we realized it actually very quickly, like a month before PHP 3 came out. Andy and I had a kind of exchange. We were benchmarking it against Perl, of all things, and the number was just horrid. And we were trying to understand why, and then slowly but surely we realized that we're actually not professional compiler techniques people, and we did do better than PHPFI, but we implemented it in kind of a dumb way still. To try and illustrate what was wrong with it, essentially with PHP 3, as it was running over your code, let's say you had a loop that was iterating 1,000 times, PHP would actually parse the code inside that loop 1,000 times. just literally go almost back to the text and understand it again and again. Those of you who have any background with compilers know that compilers don't do it that way. If you're probably familiar with Java and the notion of bytecode, so you take the syntax, you take the source code, you compile it into some other representation that is much easier for a computer to execute. With PHP 3, we just weren't doing that. What we were doing, we had all sorts of clever tricks, like a token cache and all sorts of creative things to speed up that fundamentally broken approach, which did enable us to be significantly quicker than PHP-FI, but still way slower than pretty much any other language. And our reference language back then for performance was Perl. So very quickly after that, even before it was released, we started working on a new rewrite. The main difference was that now we were no longer in a position to kind of revolutionize the syntax because there were a lot more people using it. The amount of users that started using PHP 3, even before it was GA, was just exploding. And we had to maintain Downs compatibility. It was released about 2 years after PHP 3, and it featured several elements. The first version of the Zen engine, that with a lot of changes over the last 15 years, but still conceptually very similar in design all the way back to 2000. So essentially, you now had a compiler component that was understanding, parsing the source code, turning it into some sort of an intermediate representation, and then a separate component, an executor, that was going over this intermediate representation and executing on it. It was way faster than PHP 3, and it was also a lot modular, and the modularity allowed for something called language plugins. So if you guys are using debuggers or opcode caches or all sorts of things like that, things that actually plug into the language and change, kind of do brain surgery on the language engine itself, this became possible with PHP 4. It was downwards compatible, almost completely. It was at above 99% downwards compatible. And some other thing which is unrelated but really important is that it's the first version that introduced the built-in sessions extension. And then came PHP 5. PHP 5, contrary to popular belief, PHP 5 did not introduce objects into PHP. They existed actually all the way back to PHP 3, but it's the first version where we had a true object model. PHP 4 and earlier, if you sent an object to a function, or if you return it as a return value, you would actually be sending or returning a copy of the object. Essentially, back then, objects were just syntactic sugar for arrays, like a nice notation for arrays, but it didn't behave like an object-oriented language. And this created two things. First, an explosion of ampersands in PHP code, because you try to send as much as you could everything by reference and return everything by reference, but it's not always possible to really emulate a real object model with passing everything by reference. And secondly, a lot of patterns just weren't implementable in PHP, which was holding the language back. And at some point, we decided that even though it was going to be substantial compatibility breakage, we need to reinvent the object model, and we did. And in PHP 5, we introduced the object model, which is still with us to this day, similar to Java, in the sense that when you send an object, when you return it, you're actually passing a handle to this object, so it's not a copy of it, it's actually a pointer to the very same object. And in terms of performance, it was kind of like, be thankful that we're not slower after we did all those good things for you. So putting things into numbers, this is the performance evolution of PHP from the last 4 version and all the way to the newest 5.6 version, the newest 5 version. This is a synthetic benchmark, bench.php, that is part of each and every PHP distribution. You can see that from 4.4 to 5, basically no change. By the way, this is a bit, bench.php is actually making PHP 5 looks good. In some object-oriented benchmarks, PHP 5 was actually significantly slower than 4.4. But we really didn't focus on it. We focused on making the object model work. In 5.1, we invested heavily in performance, and you can see that it's almost 3 times faster. You can see that we continued investing in performance in each and every 5.x version ever since. But you can also see that we kind of hit a plateau. In 5.4 to 5.5 to 5.6, it was like 5% gain in each version. But let me tell you that when you see a 5% gain on a synthetic benchmark, this is something that you need a very, very powerful magnifying glass to actually see in reality in any real-world workload. Effectively, if you tested a real-world app, chances are you wouldn't be able to tell the difference performance-wise when the synthetic benchmark is only within 5% from each other. Just to put things in perspective in terms of this rat analogy that I had before, so this is PHP 3. I don't have PHP FI because it doesn't run a bench.php, even though it would be an interesting experiment if anyone wants to do it, to try and kind of backport bench.php into PHP FI, but I would imagine it would be in the 150 or 200 range. By the way, lower is better, just in case it's not clear. That's seconds to run the benchmark. PHP 6, yeah. So PHP 6, it did exist. It did exist. It was never released, but it did exist for several years. The premise was to take PHP 5, not do pretty much anything else, but Unicode enable it. And by the way, those slides are taken from a presentation. The next 2 slides are taken from a presentation by Andrzej Zmijewski, who spearheaded the PHP 6 project. I think I have a link to it later on. Quite a nice presentation if you want to acquaint yourself with what happened there. It was supposed to make Unicode a first-class citizen in PHP. So you can see here 2 examples. Of course, we're in the States, so I guess nobody cares about anything about English, right? But just in case you do, then you see the first example is taking str to upper of a lowercase German word, and this weird thing you see here after the U and before the B is a double S in German. It's the lowercase double S. So in PHP 6, if you do this, str to upper on this, you will get Fußball. With double S, it does that automatically for you. And the same thing here with Greek. You do str to lower on uppercase Greek word, and you'd get the lowercase Greek word. Essentially, all of the different facilities and functions of PHP were to become Unicode aware. So that was the premise. It was kind of an important premise and worthy cause, and we worked on it quite a bit. But at some point, 2 things happened. One is that it was kind of difficult. We picked, not going to bore you with the details, but we picked the UTF-16 representation. I'm guessing that most of you are very familiar with UTF-8, which is kind of the standard today. UTF-16 is a lot less popular, but we decided for whatever reasons to use it. Probably a bad decision, and it was just very difficult to convert all of the extensions and also the language engine itself to make it Unicode aware. And development kind of plateaued. We kind of hit a wall in terms of development. Not that it was impossible to continue, just no one seemed to have the energy to do it. Maybe going back to the presentation from 3 hours ago, the developers ran out of mana. And then, at some point, I asked Dimitri to check where things were in terms of performance for this work in progress. And he did, and this is what we found out. Essentially, here, higher is better. This is requests per second. So basically, PHP 6 was half as fast as PHP 5. And as a special bonus, it will also consume roughly twice as much memory for the same request. So in terms of density, in terms of how many requests you can serve with the same hardware, it was something like 3 to 4 times slower or worse compared to PHP. PHP 5.3, well, mind you, actually PHP 5.3 then evolved and got even better, but even compared to 5.3, 6 was way worse. And at that point, we decided to kind of put PHP 6 out of its misery. And that's another slide from Andei's presentation. I'm not exactly sure what that second is, by the way, because he has the time of death down to the second. I guess this is when he sent the email to internals that it was dead. But I actually never checked what exactly that second was. But it was officially pronounced dead, and we decided to continue evolving PHP 5. And that was the decision, by the way, I think 5.2, I think, was the version that was out there at the time, and 5.3 was work in progress. And those of you who remember, 5.3 then became kind of a bit of a bloated mini version. It was full of new capabilities. It was also bulk compatibility pretty significantly in 5.2. It was kind of a major version in disguise, but what PHP 6 made us do is essentially continue the 5.x bench for 6 or 7 more years. Which brings us closer to this age, PHP 7. So leading up to PHP 7, the 5 family, the 5 bench was with us since essentially 2004. It was already 10 years old. Architecturally, it was more or less the same with substantial evolution, but again, no evolutions. And in 2012, we started researching the possibility of introducing JIT into PHP. We felt that we hit a plateau with kind of the conventional improvements. You could see that in the benchmarks that I've shown before, the 5% in synthetic benchmark. Synthetic benchmarks were really meaningless. We knew that we had to do something different, something pretty more on the evolutionary side in order to continue improving performance. So we started implementing JIT. And I don't know if you can see, but on the right-hand side, you have bench.php broken down to its various tests. Essentially, bench.php runs many different synthetic benchmarks. And if you can see, I'll tell you that if you look at the bottom line, with JIT off, the benchmark took about 1.2 seconds, 1.15 seconds. And with JIT on, which was experimental, but it was kind of working and providing the correct results, it only took 0.2 seconds, so almost 6 times faster, which was kind of really nice. So of course, in the beginning, that's pretty much all the JIT implementation managed to run. And then once we had those very encouraging results, we decided to kind of continue the work and see what happens when we run WordPress on it. WordPress is our kind of go-to benchmark for checking performance differences between versions. And we were very, very unpleasantly surprised to see that the performance gains range between -1% to +0.5%, which is effectively no difference. It just didn't move the needle at all. JIT on, JIT off, just didn't seem to make a difference. We were kind of stumped. We didn't know why that was, and we're actually working with folks from the Inter compilers division and some other divisions, trying to understand what was going on here, because it was really weird. It was supposed to be a lot faster. You try to understand where this kind of the gains are disappearing into, and to be honest, we didn't really have a clear-cut answer, but we had a theory. The theory was that because of the amount of data, the amount of memory that PHP is moving around all the time during requests, and the fact that PHP wasn't all that efficient in terms of how it was using memory, this is creating a bottleneck that is not allowing the JIT advantage to be realized. It was creating a phenomenon, a CPU side effect called bench mispredictions. I don't know if people are familiar here with bench prediction, but CPUs constantly try to guess what's going to happen, and if they guess it correctly, then they execute the code faster, and if they guess it incorrectly, there's a tiny performance penalty, but more importantly, you're not getting the benefit of a correct guess. So what was clear that we were seeing a lot of bench mispredictions, and we had a theory that was related to the memory performance. So we decided, not after a lot of reflection, a lot of thought, we decided to try and do some pretty serious brain surgery on PHP itself, and try to make the data structures of PHP a lot more compact. And it sounds, I don't know what it sounds like, but it is very, very difficult. Making, even small changes to PHP's basic data structures, the Zeev, which holds values, and the hash table, and all the kind of basic data structures of PHP. 2 hours worth of changes into those data structures can translate into a few months of work, kind of fixing and making all of the other hundreds of thousands of lines of code that use these data structures work again. So we're kind of hesitant to go ahead, but we try to anyway. And we split for the mainstream PHP in early 2014. The goal was really just to stay compatible and use more compact data structures. And within about 3 months, we got into a situation where the code managed to rebuild again and actually was also capable of running bench.php. So bench.php ran a bit sooner than WordPress, and it showed it showed some pretty good results, but we were already kind of battle tested, and we knew that the fact that bench.php was running fast was really no indication for what real-world workloads are going to look like. And then a few weeks later, it ran WordPress. And then, this is Dmitry Strogov, the lead developer that worked on this project. And then I wasn't with him because he's based in St. Petersburg in Russia, but I can imagine that when he first saw the WordPress results, and after he made sure that they're actually correct and it wasn't, the output was correct and it wasn't just a fluke, I imagine that this is probably what he looked like. So you can see my amazing Photoshop skills. It ran fast. It ran, I think, about 30-something% faster. Ran WordPress about 30-something% faster compared to PHP 5.6. That was big. I don't think that at any point since maybe the switch from the RET architecture to the Zend engine architecture, except for that, I don't think we've ever seen such a performance jump in a real-world apps in a PHP version. And we knew that at this point, we kind of like, okay, forget about JIT. This alone is pretty strong. Let's see if we can get the community to align and release this as a major PHP version. So a few months later, we moved into a public community project, and we merged it back after a vote in August of 2014. The vote was almost unanimous. There were 2 people that voted against for whatever reason, but there was consensus pretty much that this should become the basis for a new major version. Then there was a very long discussion on whether this version should be called PHP 6 or PHP 7. I was the proponent of using PHP 7, which ended up winning at the end. Another thing which is important to realize is that the performance of PHP and G, as we called it at the time before it was PHP 7, PHP Next Generation, it actually, the 35% gains on WordPress, that was just kind of the starting point. We managed to continuously improve the performance during the year or year and a half following the creation of the project. And today, actually, you know what? I'm not going to change my order. We'll get to it in a couple of minutes. But it ended up running most keyword apps twice as fast compared to PHP 5.6, which was just well beyond our expectations. Again, if you remember what I said 5 minutes ago, this was thought of as kind of step one towards JIT, to kind of eliminate the bottleneck so that when we introduce JIT, we'll be able to realize some performance gains. Practically, it showed us such amazing performance gains, and we found that we could continuously improve it to the point that we saw 2x performance gains without JIT, that we, at that point, said, forget about JIT for now, let's just focus on that. Quickly, I'm assuming that most of the folks in the audience are not C developers, so usually don't worry so much about this resolution of memory, but most of the performance gain was realized from what you see here on the left. The data structures were kind of on a diet, and they shrunk. The Zeev, which is the data structure that represents every value in PHP, anything between from an integer or Boolean and all the way to an object. It shrunk from 24 bytes to 16. Doesn't sound like a lot, but you have potentially hundreds of thousands of those in a complex request, so it made a lot of difference. And the bucket, which is kind of the container holding Zeevers inside things like arrays or objects, that also went down from 72 bytes to 32 bytes, which is even more far-reaching, and the hash table itself, which is used all over PHP for things like arrays, went down from 72 to 56 bytes. So those changes, those small numbers, once you multiply them by the thousands or tens or even hundreds of thousands of times they're being used in requests, those made a lot of difference. And it's not just the fact that it was using less memory, it's that too, but it's also the fact that when it was moving those data structures around between functions back and forth, it had a lot less data to move. And to this date, when CPUs have to go to main memory, it's way, way slower than if they're using localized memory on the chip itself, on the CPU itself. So this diet made a big difference. Another independent change that we did is we made the memory manager significantly more optimized, and today, in an average request of WordPress, the overhead of the memory manager went down from 20% of the time to 5% of the time. So those are probably the two most important contributors to the gains in PHP 7. So what's in it for you? It's fast. We've hopefully kind of established that, but I want to show you a couple of more data points. First, the same performance benchmark that I've shown before. So more than twice as fast. PHP 7 is more than twice as fast compared to 5.6. And this time, it's not just synthetic benchmarks that are fast, but also real-world performance. And this is a case study that I assume that some of you have heard of. It's a Russian company named Badoo that a lot of companies are moving to PHP 7 and are seeing great results. The special thing about this company is that they really tracked each and every step of the way, and they published a very detailed case study about their experience. So you can kind of see what kind of gains they realized by moving to PHP 7. So on the left-hand side, this is the memory utilization per request, average memory utilization per request. It went down from about 35 to 40 megs all the way down. It's not quite 0 because the scale starts at 5, so it went down to about 4. So not changing the code at all, moving. Yeah. It's kind of, Rasmus calls it, I think, kind of like black magic, and I tend to agree. Not changing the code at all, getting the same results, that's important too, right? It's not just that it's doing something, it's doing the same thing, but consuming about 8x less memory. That's pretty remarkable. And on the right-hand side, you can see the CPU load on the server as it went down. You can see that the first three kind of teeth, the spikes, is with PHP 5.6, and then afterwards it's PHP 7. You can see that the CPU load went down substantially. This company, again, I actually, for those who find it interesting, you can search for the Badoo and PHP 7 on Google, and you'll find it very quickly. There's a Russian version of it, but they would nicely enough to also translate it to English. They estimate that they saved about $1 million upfront moving to it, and they estimate that the ongoing savings is going to be at $100K per year just for moving to PHP 7, and that's just one company. So this is really, really nice. Some other workloads to illustrate that this is not just a one-off with Badoo. So you can see here, probably none of you have heard of it, but there's Zen Framework on the left-hand side, which is 2.3 times faster. Not going to go over each and every one, but you can see a lot of reword apps, and on the right-hand side you have the Laravel Skeleton app, which also is twice as fast, PHP 7 versus 5. Just replacing the language engine, the language version, and typically not having to do much more than that, and you get this instant performance boost. By the way, most of the incompatibilities that do exist in PHP 7 are not because of the engine work, the refactoring. We managed to retain, I think, above 3 nines compatibility from 5.6 to 7. Almost all of the compatibility breakage was essentially informed decisions taken by the community with RFCs and votes to remove deprecated functions or change behaviors in certain areas. So they come from that, not because we had to change something in the language engine itself that was incompatible. Some of you in the audience, I guess, probably thinking, okay, that's nice, but what about HHVM? Anyone here using HHVM? Why? Yeah. So this is compared to HHVM. This is 7.0 compared to 3.10. I think HHVM is up to 3.11, and 7 has also progressed a bit since. But the numbers are pretty much the same. In most workloads, PHP 7 is either as fast as HHVM or slightly faster. The only exception that I'm aware of at this point of a kind of a mainstream app is MediaWiki, where HHVM is a bit faster than PHP 7. But I think it's fair to say that with PHP 7, the performance difference between HHVM and PHP is no longer much of an issue. And take into account that this is still with PHP 7 not having employed JIT. And we are flirting with the idea of working on JIT in the future, in which case it may even be more favorable to PHP. Those of you who want to get some more information can find some information about the performance evolution of 7 in the first link, bit.ly/php7perf. And this, let's see if internet works. Last time I did something that took me out of PowerPoint, I getted it. Let's see if it's not even managing to get me out of PowerPoint. That's it. Okay, so I'm done. Yeah. Yeah, okay. Hey. Yeah, no, just have a bit of patience, folks. It worked fine. Okay, it just opened here in the background. Anyway, it managed to load. So this is a Mandelbrot implementation in a lot of different languages that we use to also kind of benchmark PHP versus other languages. I know all of you, probably in your spare time, you develop Mandelbots for your web pages. So it's not really all that much representative of real world, but it is representative of kind of the raw language execution performance. And you can find here implementations for most popular languages, including, where is it? Okay, here are the results. So including Java and Lua and HHVM, of course, and Squirrel and Python and so on. So the one curious thing that I wanted to show is that PHP 7 JIT, the implementation that is not available, I mean, you can play with it, it's public, but it's not production of in any sort, it was actually faster than GCC. So taking a C implementation. Now, before you tell me, that this cannot be, and to a degree you'd be right, because it's kind of the truth, but not the whole truth. There is a sensible explanation to this. GCC minus 02 basically doesn't take advantage of specific instruction sets of a given CPU. So it's creating a code that probably still runs on 386. Our JIT compiler used LLVM, which in runtime it was checking what kind of CPU am I running on, and generated code which was tailored to the CPU. So that's why you're seeing this kind of counterintuitive situation where PHP with JIT was actually faster than GCC. If you took GCC and you created an optimized binary for your core i7 or whatever, then it would be faster. But still, it's a portable binary would actually be slower in C compared to JIT. So that's a nice milestone. And you can dive more into the other benchmarks here if you're interested. Some other things which are unrelated to performance in PHP 7. So my favorite is probably the ability to do try and catch on engine errors. Beforehand, you had to use an error callback, and that was not very easy, and it was also kind of difficult to make different error handlers play nice with each other, so kind of creating encapsulated code was difficult. Now it's kind of a no-brainer. It's significantly easier and completely encapsulated. Return type declarations and scalar type hints. Return type declarations, kind of intuitive, the same thing that you could do with function arguments. Give them type hints. You can now do also with return values. And scalar type hints, which were added to PHP. I don't know if any of you in the audience followed the world war that existed around that discussion. I was on the camp that really thought that it was a bad idea. I still don't think it's a great feature. I decided to support it kind of for world peace at some point. But there are actually two flavors of scalar type hints in PHP 7. Both of them are not very good in my opinion. My recommendation to you is not to use them, but it's a free word, so do whatever suits you. Zero cost assert. Assert is with us for a long time, but in PHP 7, it now makes really a lot more sense to use it and use it extensively, because if you turn it off in configuration, there's zero impact to performance. So you can really populate a lot of asserts in your code and use that to find issues during development and testing, and then turn it off in production and not have essentially any penalty. The syntax also improved, and now you don't have to mess with something which is kind of like eval. You can use more natural syntax. Some other notable features which are not all that useful, but still cool. So we have the TIE fighter, the spaceship operator, or the TIE fighter operator, which is useful pretty much only when you're developing comparison operators. So essentially, it's going to return, I think, a negative -1 if x is smaller than y, a positive 1 if it's the reverse, or 0 if they're equal. So it's useful really for creating comparison operators and really not anything else. Uniform variable syntax, which if all works well, it's kind of should be almost completely transparent. The only situation, the only downwards compatibility issue is with code like this. Note the $ here. So that's actually not a very common construct. But if you do have this construct, then it's going to be understood differently in PHP 5 compared to 7. So in PHP 5, it kind of first evaluates that part of the expression and then dereferences foo. In PHP 7, it would be the opposite. It would first dereference bar of foo and then use bars. Use parentheses, okay? Don't rely on the order of variation for things like that. Abstract syntax tree, which is not really all that interesting for the end user, except for the fact that it enables tool makers to tap into PHP's syntax very easily and create all sorts of interesting analyzers, syntax analyzers, and IDs, and so on. Filtered and serialized, that can help you improve security to some degree. It's not really foolproof, but it can help. And the null coalesce operator, which is more or less essentially equivalent to the 3 operand operator, but actually allows you to save some keystrokes and performance. It's not just keystrokes. You can have a complex expression on the X side, and unlike using the right-hand option, it will only be evaluated once. So if you have this pretty common situation where you want to test something, and if it's available, not null, then use it, and if not, use a default, then this operator is useful for that. For the full list of news in PHP 7, you can get to the official php.net list of new features. I should have asked this before, but how many of you are using PHP 7 already? What am I doing here? Okay, going forward. So, that's awesome, by the way. By far the most upgraded conference I've ever been to so far. I guess if I ask who's not using it, nobody's going to have the guts to raise their hands, right? So going forward, so PHP is, first of all, 7.1 is feature complete already. We're expecting it towards the end of the year or maybe early next year. Don't expect evolutionary updates of the sort that were introduced in 7, but there's a bunch of nice features in it. You can go to rfc.php.net, to wiki.php.net/rfc, and on the right-hand side there's, you know what, I can, should I try that again, or maybe not? That's, so you can just go here to the PHP 7.1 section and see all of the different RFCs that we implement in 7.1. PHP 7.1 is actually 25 to 30% faster than 7 in synthetic benchmarks, which translates into 3 to 5% speed up on reword apps, which is nice. It's pretty remarkable if you remember the kind of performance gain we've seen in the 5x. That's more than what we saw in most versions. So we're squeezing performance even still. And we do have plans, as I was saying beforehand, to try and re-implement JIT and see whether now it's actually moving the needle, whether this whole theory about the bottleneck of memory usage had any merit, or whether we just ended up stumbling upon this performance gain by mistake, which is still great. Okay, so I think, if I'm not mistaken, this is the last slide. I have no idea what the time is. I'm being shown this, so thank you. I was planning. Okay. Ooh. Okay, that's my signature throw. No, not this one. Thank you.